All right. Hello again. All right, we're covering the last section in chapter 10 here, 10.9, which deals with systems of inequalities. So we are back to graphing. Okay, so systems of inequalities. This one is not as long as that last one. Okay, so let's take a look at the process for this. Okay, so the first thing you want to do is determine if your graph is going to be dotted or solid. Okay, so determine if graph is dotted or solid. Okay, so these are inequalities. So if you have a strict inequality, strictly less than, strictly greater than, then you will have the dotted graph. Okay. If you have the less than equal or greater than equal sign, then you will have a solid graph. Okay. So here you're probably familiar with this with lines. It's just that now we're doing lines, we're doing circles, we're doing parabolas. Okay. All right. So the second thing is to, once you know what it's going to be, dotted or solid, then go ahead and graph the equation. Okay, so I put this in quotations because you don't have an equation, you have an inequality. Okay, but you graph the equation part, so the circular part, or the line part, or the parabola. And the inequality part happens with the shading. Okay, so we're going to do the graph of the equation first, and then you're going to choose a test point. And so long as you choose a point that's not on the graph, so not on the line or not on the circle, not on the parabola, and not really close to it, because if you graphed it kind of messy, then maybe your point that you chose is actually on the other side. And so when you're choosing this test point, you're trying to figure out which side to shade. Okay, so it's very important that it's the point that you choose is clearly on a side. So don't pick it anywhere near the line or anywhere near the circle. Okay, away from it. Okay, so choose a test point, and it can be anything except for anything on the line, on the circle, on the actual graph. Okay, so when you choose that checkpoint, you're going to substitute it into the inequalities. And what's going to happen is it will either work or it will not work. Okay, so you'll either get a true statement or you will get a false statement. Okay, so if it's true, you're going to shade the side with the test point. So the side that your test point came from, that's the side you're going to shade. Okay, if it's false, then you will shade the other side. Okay, all right, and then the last thing here, since we're dealing with systems of inequalities, so what you're going to do is you're going to do that for each equation or each inequality that's listed, and then the common shaded area is going to be your final answer. Okay. All right, so let's have a look here. All right, so let's take a look at this example. Suppose that we need to graph this system of inequalities. Okay, suppose that I have x squared plus y squared less than 25. Okay, so hopefully you recognize that as a circle. Okay, and x plus 2y greater than or equal to 5. And hopefully you recognize that as a line, okay? All right, so let's get information about each one. Okay, so we know that the first one, x squared plus y squared less than 25. We know this is a circle, and we know that it's going to be dotted, not solid, because it's strict inequality. We know that the center of the circle is at 0, 0. Okay, and we know that the radius is going to be 5, square root of 25, so 5. Okay, so let's go ahead and graph that. Okay. All right, so the center of our circle is here at 0, 0. The radius is 5, so I'm going to go 5 units, north, south, east, west. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, and I can already tell it's going to be a little sloppy here, but okay, so it's going to be a dotted, not a solid circle. So do the best you can. Okay. All right, so we have this circle centered at 0, 0, radius 5. Okay. If I choose, I'm going to choose any point. 0, 0 is the easiest. 0, 0 is not anywhere near the circle, so I'm going to use that for my test point. Okay. All right, so my test point is going to be 0, 0. So I'm going to plug that into the circle, the inequality, x squared plus y squared less than 25. So 0 squared plus 0 squared less than 25. And I'm going to check to see if I get a true statement or a false statement. So I get 0 is less than 25. Clearly that's true. Okay, so that is a true statement. 0, 0 is on the inside of the circle, not the outside of the circle. Okay, so those are our two sides. Inside the circle is one side. Okay, outside the circle is the other. Okay, the point that I chose to test was 0, 0, and 0, 0 lies inside the circle, and it turned out to be true. So I'm going to use a yellow. Okay, so I'm going to use yellow here. So this here inside the circle is my solution set for the circle part. Okay, now I'm going to go ahead and do the line. Okay, so we know we have x plus 2y greater than or equal to 5. This is a line, so I'm going to do this method. When x is 0, y is 2.5. When y is 0, x is 5. Okay, so 0, 2.5, 1, 2.5 right here, and 5, 0. So that looks like it's on the circle there. 1, 2, 3, 4, 5. Okay, and this is going to be solid. Okay, so I'm going to go ahead and draw my solid line. Okay, and now I have two sides to the line. So you have to kind of ignore the circle right now and pretend it's not there and that you just have this line. So we have two sides of the line. We have above the line and then we have below the line. Okay, so I need to figure out, am I going to shade above the line or below the line? Okay, so I need to choose a test point. So again, I'm going to choose 0, 0 since it's not on the line. It's not anywhere close. Okay, so my test point is going to be 0, 0. And I'm going to plug it into this linear inequality here. So 0 plus 2 times 0, is greater than equal to 5. So let's see if it's true or false. So here I get 0 is greater than or equal to 5. Okay, so that's false. Okay, and I see that my test point, which is here, is below the line, and it turned out to be false. Okay, so it turned out to be false here. So I'm not going to shade below the line, I'm going to shade above the line. Okay, so let me go ahead and take this highlighter. Let me pick a nice, let me choose this color. Okay, so I'm going to shade above the line because 0, 0 did not work for me. Okay, but the solution to the system is where the shaded areas overlap, okay, where they have common solutions. Okay, so here I can see that where they have common solutions is right inside here where they overlap. Okay, so this here is my final solution. Okay, right in here where the green and the yellow were overlapping. Okay. All right. So we could erase all that extra green and all that extra yellow. We can erase that and then just leave the gray part, the gray shaded area. Okay. Let's do another one. So I'm guessing maybe some of you guys might be having trouble with the circle. So let's do another one with some circles. Okay. We'll do 2 circles. That way you can see a little bit more examples with them. Okay, suppose that you have to graph this system. All right, suppose that you have this inequality, x squared plus y minus 2 squared less than 16, and x minus 3 squared plus y plus 1 squared less than 4. Okay, so let me just show you. The equation, not inequality, but the equation of a circle looks like this. This is the general equation of a circle. Okay, so, and if it's written in this form, then you know some things about it. You know the center is at HK, and you see here it's minus H and minus K, so it'll be the opposite, okay? And your radius would be R, not R squared, but R, okay? All right, so let's take a look at that first one. X squared plus y minus 2 squared less than 16. This is in standard form, okay, of a circle. So I know this is a circle, and it's going to be dotted, okay? And the center is going to be at, there's nothing with the x, so there's 0. And then you have that minus 2 with the y, so it's going to be opposite, positive 2. Okay, so center is at 0, 2. Okay, so let's go ahead and graph that. Oh, and my radius. My radius is not 16, but the square root of 16, which is 4. Okay, so 0, 2 is my center. And I have a radius of 4, so I'm going to go 4 units up, down, left, and right, north, south, east, and west. So 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. and 1, 2, 3, 4. Okay, dotted circle. Okay. All right, so we have this dotted circle. We need a test point. So I will use 0, 0. Yeah, 0, 0 is not anywhere close to the circle, so I'll use that one. So plugging it into the inequality there, let's see if I get true or false. So I get 0 plus 4 is less than 16. 4 is less than 16. That's true. Okay, 4 is less than 16. So I'm going 0, 0 is inside the circle, not outside the circle. So I will shade inside the circle where 0, 0 is, which is right there. Okay. So this is the solution to the first inequality. Okay. So now let's do the second inequality, which is also a circle. I'll do the information over here. Okay, so we have x minus 3 squared plus y plus 1 squared less than 4. Okay, so this is a circle. And it's going to be dotted as well. Okay, and the center is at, we have a number there with x. We're going to take the opposite, so positive 3, and then negative 1 for the y. Okay, and then the radius here is going to be not 4, but 2, square root of 4. Okay, so it's going to be 2. All right, so let's go ahead and graph that. Center at 3, negative 1. And I have a radius of 2. So 1, 2, 1, 2, 1, 2, and 1, 2. So itty bitty circle over here. Also dotted. Okay, I can choose 0, 0. 0, 0 is not on the circle. Okay, so ignore that bigger circle. Okay, so my test point for this little circle, again, I can choose any point that's not on the circle. I can choose a point inside the circle or outside the circle. So I'm going to choose 0, 0, which is outside of that little circle. Okay, and I'm going to plug that in to the equation. So I get 0 minus 3 squared plus 0 plus 1 squared less than 4. Okay, so that's going to give me 9 plus 1 is less than 4. 10 is less than 4. Okay, 10 is less than 4 is false. Okay, so 0, 0, which is outside that little circle, did not work. So instead of shading outside the circle, I'm going to shade inside the circle. Okay, so let me choose this one. So I'm going to choose inside the circle. Okay, and then we can see here where they're overlapping. Okay, so where they overlap is going to be the final solution. Okay, so we see that the green and the yellow are overlapping right inside here. So that would be my actual solution to the system, because those are the x and y values that actually will work for both inequalities. Okay, all the stuff in the yellow works only for the first inequality. All the stuff in green only works for the second inequality. But the stuff that they have in common works for both inequalities. Okay? All right, let's do one more with a parabola. So just to see if you remember how to graph those using shifting. Okay, so let me get my pen back. All right, let's graph this this one here. Y is less than or equal to 9 minus x squared. You only have one of them squared. When you have both of them, it's probably going to be a circle because we haven't done the other conics yet. That's coming up in the next unit. So if you have both of them squared like you did here, those are circles. Okay. If you only have one of them, it's going to be a parabola. Okay. X greater than or equal to 0, y greater than or equal to 0. Okay. All right. So I'm not going to do the parabola first. I'm going to do these two first, the x greater than or equal to 0 and the y greater than or equal to 0. Those are very easy. All right. So x greater than or equal to 0. Okay. So that all the x values that are larger than 0, well, 0, here's your x's, right? Here's 0. All the x's that are larger than 0, this side, right? So all of these points on this side have x values that are greater than or equal to 0. Okay, so there, I'm done with that second inequality. Let me do the bottom inequality, y greater than or equal to 0. Okay, so here are your y values, right? Vertical. And here's 0. So all the y values that are greater than 0 are all the ones above, right? Okay, so all of these have y values that are greater than 0. Okay, so far from here, we can see that we are going to be in quadrant 1. So whenever you see this combination right over here, whenever you see this, all the x values greater than 0, all the y values greater than 0, that automatically puts you in quadrant 1. Okay, so we see that the common solutions so far are all the points in quadrant 1. So I don't even need this, and I don't even need these. Okay, all right, let me take that off. Okay, so let's graph that parabola up above. Okay, so that first one, I'm gonna write it like this. So maybe it'll look a little more familiar. So you're probably used to seeing it like this. Okay, so this is a parabola that will get shifted up 9 units, and the original y values get multiplied by -1. Multiply original y values, okay, by -1. Okay, so let's go ahead and do that. Okay, so if you remember, a parabola, the original parabola has these 3 points, right? Okay, those 3 points. But then multiply them by -1, and then now we have this one, this one. Oops, that doesn't look like -1. Let me do that one over. And this one. Okay, because you multiply the y values by -1. And now we're going to shift these all up 9 units. Okay, so let me use red as my final. Okay, so I'm going to take those blue points, shift them all up 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And same thing with the other two. 1, 2, 3, 4, 5, 6, 7, 8, 9. And same thing with the other one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And this is going to be a solid, okay, a solid line. So it looks like this. Okay, there's my parabola. So my two sides of the parabola, below the parabola and above the parabola. So I need a checkpoint. 0, 0 is not on the parabola, so I can use 0, 0 as my test point. Okay, so let's plug those in and see if we get a true statement or a false. So 0 less than or equal to 0 plus 9. 0 is less than or equal to 9. That is true. Okay, and 0, 0 is below the parabola, so I am going to shade below the parabola. Okay, and let's see. I already have green. I have yellow. I'll take this magenta. Okay, so this is what I have, right? So hopefully you can see that where the three inequalities overlap are right there in quadrant 1. Okay, so my final solution is right in here. So everything in here, okay, in quadrant 1 below that parabola, okay, and nowhere else, okay? So I could erase all the other stuff, okay? So I definitely don't want this down here, okay? I don't need that, okay? I don't need this anymore, okay? I don't need those, okay? I don't even need these, right? I don't need that. It's just that little piece right there, okay? Let me put this back. Okay, so that would be my final solution, that gray area, okay? All right, if you have any questions, make sure you email me or message me through the Remind app. Keep up with your homework, and don't forget to drop by November 13th if you don't think you want to continue. All right, see you next time.